Thank you, Jason. Good morning, everybody. Thank you for joining us. We're going to be covering a whole bunch of information here. If you have questions, as Jason said, just type them in, or my email is down on the last slide, so I'm happy to help at any point. We're going to be covering some things about codes, and a lot of the stuff that we're going to be talking about today relates to codes, but also is about building performance. It's about systems. It's about some of the new stuff coming out. And I'll be mentioning as we go through here a little bit about what I'm expecting on some of the new codes, particularly the energy code. But one of the things, or a couple of things we're going to be talking about here, we wouldn't have buildings if we didn't have people. And that's the whole reason for buildings, to contain things that relate to people and what they do. And there's a relationship there. That relationship is changing. As it started to change a couple of years ago, and this pandemic stuff has accelerated that. So we're going to be talking about the relationship between people and an interesting study that Harvard has done. And then how do we analyze this? And this is as much about your building operations folks for your city or state or whatever, or commercial projects, how they optimize their buildings. What systems do you need to look at? We're going to be concentrating on air conditioning and a little bit about plumbing and lighting at the end. So there are some new things coming out that might be of interest. You'll be seeing in the codes and seeing in the inspections and the building performance for a while. Then we're going to talk about some options and things that the building people can use. There are some interesting things that are happening on, like airport facilities or university facilities, that they're making grand decisions that don't work out real well because they don't understand the implications. And there are, as I mentioned, some code-related issues here. So let's start with people and buildings. People in the buildings, it's about the health and comfort, and it's more about nowadays the experience in a building. What do the people think about it? What is their attitude in the building? That affects their productivity, and that's important for both the public facilities and for commercial and private facilities. So there are some programs out there that help the buildings succeed. Of course, LEED, most everybody knows about that, but that has transitioned in the last 10 years into more of a health-related opportunity. And well building is one of the programs that it's available now, and it is more about health, where LEED is more about energy and efficiency and sustainability. Fitwell is another program that's parallel to well building. Well building is difficult and expensive to document. Fitwell isn't quite as broad a program, but it is a lot easier to use. Now, of course, you've got, and most everybody on this call read, on the codes and standards, get the ICC codes. But we're going to talk a little bit about more for the CDC, Center for Disease Control, and for ASHRAE and some of their programs. Then if you look at the buildings, it's safety. We'll talk about a little bit about codes and how that's evolved, but that's what building codes started out to be, is safety. Then they talk about function nowadays more than they used to, and they talk about efficiency. And all of these things now are relating more to building and health. So what are we looking at? The first thing, as I just mentioned, the buildings are about people, and the occupants have needs. And more these days, it's about the attitude and the participation of those folks. And the capabilities of the building need to be, and the operations need to be taught sometimes to the building occupants, but it makes training. And sometimes, and most everybody is familiar with these, the CDC and the health departments are talking about, and I'm calling it occupant management. And that includes the things that everybody's talking about, masks and hand washing, all the rest of that kind of good stuff. That is really important, that regardless of what the building systems do, these things are important for people to understand, and that takes some training too. And then you talk about building systems, cleaning, and all the rest of that. And if you have a building that's shut off for a while or not used for one reason or another, and then you're turning it back on, there are some things that you probably need to clean and look at that is going to be important to the health of the folks in the building. And some of these things that you're doing, and like high-rise buildings, are looking at different kinds of elevator controls and all the rest of that. So there may be some building modifications necessary on some of these things. But there are, you have to provide hand washing facilities and all the rest of that, and that might be some building modifications. And that might call for some building tune-up. The tune-up requirements haven't made it much into our area yet, but if you look at the East Coast and the West Coast, some of those cities and areas are requiring building tune-ups, and that's sort of a minor commissioning type function, but it's about making the building work right and making it healthy for people, and the health is becoming more and more important, in some cases more important than the efficiency. So what are we talking about in a high performance building? Why do we even care? One of the things we're talking about here is the bottom line. Occupant productivity. How do you hire the right kind of people? And the productivity is in the range of $3,400 profit per employee if you can get people to be more efficient and to work better. And we'll talk about that a lot more here in just a minute. But that's about, if you're owning the building or if you're supervising folks in the building, you're talking about $18.56 profit per square foot of your building if people work more efficiently. And how do you do that? And these numbers come from a report called the Stock Real Estate Estate Services, and that's the source for that. If you're looking for that, there's a whole report that goes through that. But as I was mentioning, there's some interesting research recently done of why you want to have buildings clean and operate right. Harvard has done a series of studies. They're on the third level of that. And if you go and Google the COGFX study, and it'll connect you to Harvard, and then that will get you all of this information if you want a copy of the standards. But what they did, on the upper picture there, you can see a office space, and this is space for 24 people. And below that space, you can see in the lower picture, that's what it looks like. So they're capable of changing the air quality in those spaces. It took, like I said, 24 people for 6 days, and they set and measured their performance on 10 different levels, but they measured it 3 different ways: with a conventional office that's not very clean, then with low volatile organics, low chemicals, but their standard carbon dioxide, in other words, not much fresh air, and then they do it with low volatile organics and low CO2. Then they checked cognitive functions, they checked a response, they checked how they used information, and they mentioned that they changed it to 3 different levels. So they're talking about a conventional level, green level, and enhanced green level. So the CO2 level, for those familiar with the various numbers, 1,000 parts per million, that's about as high as you should go to in a building. We've measured areas that are a lot higher than that. And the total VOCs are measured in micrograms. And that's one of the things that they mentioned there. And then if you go from conventional, and we're talking about the 10 things that are listed there, information usage, strategy, and all the rest of it, all the way down. And look at the numbers. On the green, if you're controlling VOCs and not the carbon dioxide, which means no fresh air, you're in the information usage performance level of the people in that space was 172% better. Look what happens when you go with low VOC and high ventilation. 300%. Your information usage efficiency, the people in that space, increases 3 times. And every one of the cognitive levels, cognitive functions listed there increased. So there's a really good reason for increasing your outside air vent and keeping the place clean and clean of chemicals. Air pays off. So if somebody hires a more capable worker, that might cost them $6,500 a year. That's more expensive per square foot for the employer. And the getting them to perform better is important. So that's give you some of the numbers there. And then it also comes from this economic development study. But how do we do this? How do we get to where we need to be? The uses of the building needs to be looked at. You need to do an evaluation, try to figure out where you are and what you need to do. So one of the things that there's a series of things here that you need to look at is, what are you using the building for? What is the function of that building and the people in that building? Secondly, you need to look at, how old's the building? What kind of technology, what kind of systems do you have, and what condition are they in? Then you need to look at the number of occupants and the occupancy schedules. Over the years, the buildings have become a lot more dense, a lot more people, and some of the designs for offices a year or so ago, they had people on about 4-foot centers, or 4 to 6 foot centers throughout the entire floor. We're working on a 1-floor computer programming system building that has about 200 people on that floor of about 25,000 square feet. So it was going to be dense. But you also need to look at what are the people using? What's plugging in? What are they bringing into the space? And then what are the requirements? What do the codes say? What does your code say? It needs to be looked at to be sure that you're up to date. And there are some other requirements. And then you also want to check what are the records? What are the codes? What is the jurisdictional requirements, and are we using those effectively? So if you look at building terminology, I mentioned 30 or 40 years ago, building codes started out, it's about life safety. And then all of a sudden in the 80s, we start talking about energy efficiency. That was, the oil embargo time. In the 80s, they're talking about everything being more efficient. So that started changing the codes and the standards. Then we went from energy efficient to high performance, which adds other elements to the building. Then that changed to green back in the late 90s, early 2000s. Green became one of the things that people wanted to be. Then that people got tired of using the term green, so they started using the word sustainable, which has other elements. And then currently we're moving towards net zero, which is going to be a big impact on codes and building operation. And then resilient is the next things that we're going to be talking about, and we're already talking about from a life safety issue. So one of the things I think from a weather issue right now, I'm glad I'm in Texas, and everybody I think listening here is pretty much in Texas, that we're not living in New York where they're going to get 2 feet of snow today. So they might have a white Christmas, but that's going to be hard to get around. So codes and standards, let's trip over to those real quick. Building codes, like I've said, the structural codes, that's life safety. Mechanical, plumbing codes, followed right along with the building codes right after that. They're talking about function and installation, be sure they work right. Electrical, that's an NFPA code. That's again talking about safety and function. The energy code came along about 15 years ago, 20 years ago, and it is basically based on ASHRAE 90.1, which is the ASHRAE energy code for commercial buildings. 90.2 is for residential, and then there's 2 or 3 other 90. There's one for hospitals and some other things. Talks about efficiency. Green code started out independently with the ICC and with an ICC committee, and then they made an agreement with ASHRAE and the USGBC to put one code out on green and sort of merge all of those. So the green code, current green code, the 15 and the 18 green code, the 18 green code, sir, is basically based on and is included with the ASHRAE 189.1 or sustainability standard. That's changing. That new code is coming out, both the energy code and the green code. The 2021 versions are not published yet. The energy code is supposed to come out sometime this spring. And it's based on the newer version of 90.1. And my expectation is there's going to be a bunch of changes to the ECC Energy Code because there is a lot of changes in 90.1. A couple of hundred changes that were proposed on that, and 100 and some of them got adopted. So that's where we're going on that. Then resilience, no codes yet, no standards yet, but we're working to that level, and we're going to have to be either including that in the current codes or put some new codes out. So here's what we're going to be talking about for a little bit here. In environmental systems, of course, air conditioning, talking about ventilation. Fresh air is a clean air. Of course, air conditioning is about comfort. Comfort part of it didn't start until the 1940s or 1950s when air conditioning came out, at least from us down here in the South. The heating has been done for a couple thousand years, but the comfort area is really important, and the health of the people in the building is becoming more and more important, and that's one of the things that we're going to be talking about here of some of the systems that do that. Plumbing is also a health issue. Of course, you got to have water. You need water to survive, but there are certain functions in the building that need to be safe and they need to be healthy. Electrical, sort of the same thing. It's more of a lighting issue, somewhat of a power issue, and there's some interesting things being developed on the power side. So what do? How do we get into this? Well, you do a building system evaluation. What's working? Is it functional? Does it operate? As I mentioned before, if you're shutting a building down, you got to reactivate it, and does it work right? And what is the performance? What are the results? What is it doing? Is it applying to what's supposed to be in the building? Then the health and safety, of course, is something that's going more and more important, but you have to figure out what the building systems are doing, what impact they have. And then efficiency, of course, is important, but that's maybe in some cases taking a second level view compared to health. And then how do you improve that? And then doing a building survey is important. How do you start with that? Well, I'll give you an example of something we just did on a school project. But one of the things that we're going to try to get this organized in the different levels. Before you start looking at a building specifically, probably need to do a plan. What is the building or the set of buildings or the city buildings or whatever? What are they supposed to be doing? What's happening in that building? What kind of plans do we have for making them work right and for improving them? Then you have to put together a group. Who's going to do all this stuff? Who's going to assess? Who's going to change? Who's going to monitor? Who's going to approve? So you need to know what the system does. And most everybody has one of those, but it's important to look at it systematically. What we find too often is building owner that says, oh, I've heard about this new fangled system, let's put those in. For example, the university, they recently decided they wanted to improve their filtration on all of the units and all of their equipment. And they says, okay, maintenance contractor, put MERV 13, 1-inch MERV 13 filters, 1 or 2-inch MERV 13 filters in all of the air handlers. Well, the smaller air handlers that had much less filtration, the filters have much higher pressure drop. And on the smaller fan coils and the split systems, virtually every one of them froze up because the MERV 13 1 or 2-inch filters pressure drop was so high that the air handler couldn't move the air anymore. So there's things you have to look at. Do it in a comprehensive way. So again, level 1 we're talking about is assessment, and this system is based loosely on the ASHRAE existing building commissioning standard and guideline. But I'm saying that assessment something you got to do. Really, you need to look at your building to see where it is, what it's doing, what you can do. Then you need on level 2 to go through and say, okay, let's test this. Let's find out what it's really doing. Let's get some numbers and performance limits on these things. Then once you get finished with that, you decide, what do you want to change? What do you want to do? What do you want to change? And we're calling that level 3. So what are we doing level 1? So we recently did, and it's important that you do an assessment. We just recently did a assessment on the outside air and the ventilation on a school that I think had 9 buildings. And of all of those 9 buildings, and of course all of them are classrooms and offices and they had restrooms and that, there was 1 exhaust fan on the entire campus that was operating. All the rest of them were either turned off or didn't have any belts. Of all of the air handlers, those that had rooftops, and there was a couple dozen of them, there was only 1 or 2 of those rooftops that the outside air was even open. So what the maintenance and the repair folks had done is, okay, we're going to save money by turning off all the outside air, and you don't have any restroom ventilation, then you don't have to you know, heat treat the air coming into the building. It didn't work real well. So things you have to do and must do, you have to turn things on. I mentioned you got to clean them, which means duct cleaning, which means changing filters, which means being sure they work. And then as you do this, as you go through each system independently, what are the minor adjustments? What are the repairs? What do you need to do to make it work right? And then you develop a list for each area and for each system. What do you need to do? What do you need to test? What more information do you need? And then you need to decide with whoever makes the decisions, what do you want to do? Where do we go? What do we want to do? What do we want to spend money on? Level 2, functional performance. What you're doing here is actually testing and measuring air flows and measuring water flows and measuring outside air flows. And then you create what the industry is calling current facility requirements. In a new building, you have what they call an OPR, owner's property requirements. The current facility requirements is what's currently the use of that building. Because buildings change. Not all the time that the buildings, and I'm sure you've seen this on your buildings, some of the times on the older buildings, they aren't used for the same thing that they started out to be. But the changes to these buildings, and we see it all the time, that they'll change the walls, they'll change the paint, they'll change the ceiling, but they don't change the air conditioning and they don't change the electrical power system. So it doesn't work real well. So what's the current facility needs, and are the current systems doing that? And then you perform adjustments, maximize the current systems, and that's part of commissioning or recommissioning. Then you evaluate your plans. Are your plans or your O&M systems, do they do what they're supposed to do? Are they maintaining the building right? And then you perform some training if you need to. And then put some options together. After you know what the real performance of the equipment is and the systems, what do we want to do to change those? So in looking at that in level 3, again, we might want to revise the facility requirements as we learn, as we go through. So none of these documents are to the point where they can't be changed. So you implement selected improvements, and we're going to be talking about some of those as we go through here. So you modify the designs, and then if you install new systems, even if you don't, you want to test them and commission them. And then you update your system, your documents, and your maintenance training. So CDC and ASHRAE have gone through and done some studies and published some recommendations. And if you go to the ASHRAE website, they've got a lot of there's whole bunches of information, as EPA does also. So their recommendations is clean buildings, make them operational. That's what we've just been talking about. They said the first thing you need to do is increase ventilation. Be sure the outside air works right. Be sure that it's doing what it's supposed to be doing. And the trick there is what a lot of the studies that ASHRAE and others have done, say optimally to get the ventilation that you need. Theoretically, you should change the air in a space 4 times an hour. In other words, outside air should come through that space 4 times an hour. Most systems won't do that. So you have to look at whatever the system can do. Then you increase filtration efficiencies. Filters have come a long way in the last few years. We'll talk about that in a minute. Then you optimize the building systems and schedules. So are they doing what they're supposed to be doing when they're supposed to be doing it? And there's been some interesting studies on humidity. We try to stay below 60% relative humidity because mold grows above 60, than the 60 or 80 or 90%. But they're finding out that viruses love low humidity. So keeping the humidity level up in the building now becomes important. So from the outside air analysis, you need to take a look at, does the system even have an outside air connection? A lot of your split systems and the little residential type systems in commercial buildings don't have outside air capacity. So how do you handle that? There's a bunch of different problems there. What are the systems? How much can they provide from an outside air standpoint? What we recommend initially for people to look at is go back to your design drawings, if available, and be sure that the system is providing the outside air it was designed to provide. That way you get at least a minimum amount of ventilation. And then look at the program, look at the code requirements, current code requirements for outside air, because the code requirements have gone up. Back in the 1980s, as we mentioned, the efficiency surge, they cut the outside air down to 5 CFM per person. That spawned the air quality industry because people start getting sick. Now it's around 17 to 20 CFM per person. But sometimes changing this you can't do real efficiently because you don't have the space to do it. And you have equipment limitations. So ventilation, you're talking about sensors and controls. And one of the things that I mentioned, the fact that outside air is not available on a lot of split systems, and this is particularly true of schools. Schools tend to use a lot of split systems and small rooftop units. And a lot of times they don't have outside air. And the new systems that just started being used not too many years ago is a dedicated outside air system called DOAs. And they supply conditioned outside air in the quantities you're going to need, and you might need to put that on some of your buildings. Be sure you have building pressurization controls. Buildings leak, and the codes are starting to change in that because some of the new codes, the energy codes and that, are now requiring building pressurization testing on residential buildings, and the next series of codes will require pressurization testing on commercial buildings. So this is changing the world as far as building optimization is concerned. And then this is done by what normally is now what we call blower door testing. You can actually test the leakage rate in a building by pressurizing the building and then measuring the airflow that's leaking. And then you do the zero leakage in testing if capable for that building. And then you look at your air handler systems and are they efficient? There's the ECM motors are a lot more efficient, and they're mostly used now on the smaller horsepowers. But getting that kind of efficiency in there lets you control your outside air because ECM motors are a lot easier to control than your old style capacitor start motors. And then what about your exhaust systems? You can sensor control those, and the trick there is that quite often people will turn off their air handlers at, say, a night or whatever, but the exhaust system stays on, which means that the exhaust system is sucking outside air into that space all overnight. So that makes it difficult to condition things in the morning. So comfort and health, we're talking about the various standards here. ASHRAE 62.1 is now divided in so much air per area and so much air per person. and that's based on what the people are doing in the space. The temperature control is based in large part on ASHRAE 55. Humidity control, again, is ASHRAE 55. It's conditions for comfort. Contaminant control, talking about various other standards and that from many, many organizations. And you're talking about ventilation there, flushing of space, monitoring it, measuring it, testing it. You can tell a lot of things with some very simple instruments. Thermostats, technology is changing on thermostats. A lot of them are now becoming wireless. You're going to have sensors on the ceiling instead of on the walls. So there's going to be some changes there. And then there's a lot of movement now towards individual control for their individual station. And that's partially fueled by the Internet of Things. And we'll talk about that again in a minute. And the records and that, this Internet of Things, everything's going to the Internet, as everybody knows. So let's talk about filtration for a minute. So filters in most of the commercial office and other buildings, and even most residential, goes from 1 to 4 inches. And each one of those filters has a pressure drop that changes as the filter loads up. So the capability of the fan has to be matched to the filter. So if you're putting higher efficiency filters, for example, there's your big box stores will sell, there's a really high efficient, like MERV 12 1-inch or MERV 13, or I think it's an 11, a 1-inch filter. It's a blue colored filter. That's a lot higher efficiency, but it has a real high pressure drop. So just sticking that in your home system isn't going to work real well. But they're of the various different types. The panels and plated, you can get sophisticated with the electrostatic or the carbon. But in looking at the various types of filters, the MERV minimum efficiency rating value is what that stands for. That's a ASHRAE standard, and that's 52.2. And the MERV ratings go up from 1 all the way to 16. And so if anybody says that they've got a MERV 17 or a MERV 20 filter, that's not rated for the national standard. So MERV 6, usually 1 inch, and looking at the various numbers, as the MERV level goes up, the efficiencies go up. Thing to think about here is we're taking the pandemic and that we're talking about viruses. Viruses are virtually all less than 1 micron, some of it down to 0.1 micron. We'll show you a picture on that here in a minute. But to get to the MERV 13, there's usually a 4-inch, but you can get MERV 13s and 2-inch. 90% of your 3 to 10 microns. And to get an idea here, like a 5 micron or a 10 micron, if sunlight's coming into a space and you can see dust floating around, that dust is probably in the 5 to 10 micron range. You're not going to be able to see a 1 micron or 0.3 micron, but in this case, the 13 catches 50% of those. Here's an idea of how big these things are. On the right side, you've got a PM10, particle mass 10, and then a red blood cell is about much smaller than that. The PM 2.5, of course, is smaller. Bacteria is smaller than that. It's down here 1 to 2 microns. But look at what the COVID-19 is way down there. It's about 0.1, 0.3 microns. Your filters aren't going to catch that unless you make that particular virus nodule clean to something else that the filters can catch. So if you look at the target levels, and I'm not going to spend much time on this slide, but there's a whole series of ratings. On the bottom, there's diameters from, again, 0.01 to 10 microns, and that's the fractional efficiency. 13, as you can see, as the numbers go up, the efficiency goes up. So most of those efficiencies are pretty good at the 0.1, 0.3, and all the way up to 10. So if you look at the table, that I'm not, again, too many numbers here for you to digest, but keeping example on, for example, a MERV 6, which is what's been used for many, many years, 35%. It doesn't have a rating for 1 micron or smaller. So you're talking about big dust. MERV 13s, 90% at 3 to 10, 85% at 1 to 3, and 50%, as we mentioned, on the small stuff. That's bacteria, some viruses, droplet, and the rest of that. So the higher the number, the better the filter, and the better the efficiency. But again, when you change filters, be careful that the system can handle it. So let's take a look at one of the new systems. Ultraviolet lighting systems maintained are getting a lot of press nowadays. So the ultraviolet lights, called UV, the C type or UVC, can be a bulb, or like similar to a fluorescent bulb, or can be solid state. And we'll get more into what the lighting thing is here in a second. The intensity of light and the frequency determine the effectiveness. For example, for 20 years, last 20 years, they've been using ultraviolet lights in tuberculosis clinics and treatment areas. But it takes UV light about 24 hours to kill one of those cells. And the UV light, even though it's promoted as killing all of these viruses, takes a while to do that. So there's various places you could put these ultraviolet lights, and we'll show you some pictures here in a minute. But you can put them in the air handler, but it's a couple of different things in the air handler to look at. One of the things that UV lights are starting to be used at is you keep the coil clean. You're stopping the mold growth and the accumulation of that on the coils. Works pretty well. But that particular kind of UV light and that wavelength isn't that good at killing viruses. You can put them in the ductwork system, you can put them in the buildings. So it depends upon what you're trying to kill. COVID-19, flu, tuberculosis, as we mentioned about. And all of these are affected by dwell time. How long is the air exposed to the UV lights? Also, you might be careful because UV lights can generate ozone. And ozone is not a good thing. It can give you emphysema and really mess up your lungs. But one of the things that you have to realize, if you put in UV, because we've got some buildings and some even school systems are saying that everything that they install nowadays needs to have UV lights in them. Well, yeah, but you have to understand what you're doing, and you have to understand what the maintenance is, because they're finding out, just read an article a couple of days ago that they have figured out that the UV bulbs, the fluorescent type bulbs that are UV, only last about a year, and they have to be cleaned periodically. So that's more maintenance. And then you have to figure out where you're going to put them when you take them out, how to dispose of them. So looking at the ultraviolet light here real quick, the ultraviolet light is just below visible. And the short wave, what they call short wave UV, is what we're trying to do here. That's around the 254. Oh, sorry about that. But that's where the UV light is in the spectrum. So we're trying to get the right light. So if you're putting UV lights in, study what you're trying to control and match that control with the wavelength of the UV light. This shows a picture of one way of doing it. And most of the time, your UV downstream for coil maintenance, keeping the coil from getting moldy, usually is downstream of the coil. The airflow is coming from left to right, and they have a pre-filter, and then you kill the virus, supposedly. But take a look at the space there between the filters and the coil. You need at least 12 to 24 inches between the coil and those UV lights. So you can't put this in just any air handler. But there's another way to do it. On the left side is putting UV lights on big built-up air handlers. If you're looking at smaller units, rooftop units and that, the coil cleaning on the lower part of this air handler shows the UV lights keeping the coil clean, but what they did is they put high intensity UV because the viruses are killed based on wavelength and UV intensity. And what they can do there is increase the intensity of the UV in that duct system, and that kills a lot more of them, than the viruses, than you could trying to put them in the unit itself in a couple inches between the filters and the coils. You can also put them in a wall-mounted area, and this on the left side shows probably a hospital room. But what they're doing there is the UV light stays up at the upper level of the room, and assuming you've got good air circulation, then the virus particles circulate up into that space and get killed by the UV light on the top. And there's also, they have fans nowadays that create good air movement, and they also have UV capability on the top of the light. That puts UV up towards the ceiling where people can't see it, because you don't want to have UV where you can see it. Put your eyes on it. If you put a UV bulb or a fixture in the middle of your desk to clean your office will get real clean, but pretty soon you will be blind and have sunburn because it's really hard on the eyes and the skin. So be careful when you put UV in that you have the safety precautions. You can also do it with room filtration. If you can't put in big filters and more of 13 or 16 filters in your air handlers, you can put units in the space. This is good for classrooms when you have unit ventilators that don't have capabilities, because what's happening there is you can have UV light in the filter, as is shown on the left side there, suck the air in, blow it out through a HEPA filter, and you get clean, sanitized air that way. So those would be good for classroom areas. You can also mount a UV system on the ceiling. And what this does is this brought UV light horizontally at the ceiling, and that'll help with the controls there. What about ionization? That's the next hot button that people are talking about. And we're only covering the main ones today of what we've got that we're looking at. So ionization systems, and I'll show you how that works here in a second. But you have problems with installation locations. There's been a lot of research, not nearly as much research on ionization systems as UV. The research and peer review is still ongoing on that. ASHRAE mentions them, but ASHRAE hasn't approved ionization systems because not enough is known about the effects of the ionization systems yet. So the effectiveness it's good, but people don't know exactly what levels. And there's large variations from various models and brands. So there's a whole bunch of things, and we'll talk about it here in a minute, but it impacts your filter loading. Now, this brings up a point that we try to make to building operators and building owners and building designers, is don't believe everything you hear and don't believe everything you read. Get some authoritative sources if you're looking at UV, if you're looking at ionization. Do some research, talk to some folks. Just because a salesman, and I don't sell any of these things, so any salesman that comes in and says the ionization systems is the best thing ever built and you need to put it in every unit, not so much. So be careful. I'm not saying don't use these, but be careful. You know exactly what you're getting. So this is what the ionization does. So what you're doing is you're imparting, and this could be by a high voltage grid or something like that, but you're energizing an oxygen molecule and you're popping off an electron. So you now have a positive charged oxygen molecule and a free-floating electron, which goes to become part of another oxygen molecule, and that gives these molecules a charge. And what this does is, since negatives and positives attract, these charged ions combine with all kinds of other floating clusters of things and make them bigger. So what you're trying to do here is ionize the things that are floating around in space, including virus particles, get the virus particle to be part of a bigger clump of dirt, which is then filtered out by your filter systems. But when you do that, a lot of the small particles become large particles and load your filters quicker. The other item you have to be careful of is the ionization systems do not kill the virus, as ultraviolet does. What it does is it takes it out by filtration. So when you change those filters, the people really need to be careful. They need to have personal protective equipment, and you need to treat the filters that might have viruses in it as like a hazardous material, and you need to bag those and get them out very, very safely. So what they quite often do nowadays, as I mentioned, the ions don't last very long. So starting them in the air handler doesn't work real well. So the idea is to get them into the air handler or into the ductwork, as close to the room as possible. Then they'll be floating around in the room and combining particles. By the time it gets to the other side of the room, the charge is gone, but the particles are there and they get caught by the filters. Now, it says, well, what happens if I don't want to do that, or I don't have a system for that? Some of these big fans, like warehouse fans, and we see these in offices also, not this big, but some of these fans have ionization units on the end of the fan, those yellow areas on the tips of the fan. Right above that is an ionization unit. They're small, battery powered. So, but they do create ions, and then they kill that and do the same kind of filtration thing, but you have to have air movement and you still have to have filters. So there are ways of doing ionization in several different ways, but it depends on what you're going to do with them. So HVAC controls, again, we're looking at other things to, sort of change gears here. So the controls of a space are important. Being sure that you're ventilating properly at the right times is very important. So those can be computer-based and programmable. Most of the new ones are. And then on your older buildings, back when I started on this, it was on-off or pneumatic, and now it's getting to be all electronic. So on the older buildings that are still pneumatic, you might have control issues, and it's expensive to put computer-based programming in, but there are options around that. So a lot of these are digital, so we'll talk a lot about the digital here in a little bit. Many of them now are wireless. We've got a wireless system in our office, controls 6 various thermostats, and I can program and set the timing on 5 of our rooftop units from my desktop. So you're talking about various controls, and we don't have time today to get into all of the details, but you can control various different things. Control fans, what the box is doing, what the area is doing. But a lot of this is eventually moving to the Internet of Things. And one of the issues, and I've talked to some of the folks at ASHRAE and that, on control programs that are cloud-based. What about security here? Can if your controls, and what they're saying is that the building controls soon for large buildings and new buildings, you will not have a computer in the building. All of the controls will be cloud-based. You will have sensors with communicators. So that means all of your programs and all of your building control is cloud-based. What keeps Ivan from Moscow from taking over your building, or whoever from Peking from taking over your building? Not much. So you have to be careful with that to be sure that those security is things. and the folks in ASHRAE that I talked to that are control-based agree. So let's take a look at the Internet of Things for a minute. So we're talking smart buildings. I've never particularly liked that term, but intelligence and all the rest of that are things that basically the building sort of reads and controls itself. So that's happening. So all of these things and that help with predictive maintenance and the rest of that, there's one system or a couple of different systems that you can put into a DDC system that monitors all of the zones in a building and monitors what it's doing. And every morning, first thing in the morning, it provides the building operator with a list of all of the things that aren't working right in his building. So it's an interesting things you can talk about. But by 2025, there's going to be 70 billion IoT connected devices, and we're going to be spending a lot of money. There'll be $1 trillion spent on IoT stuff by 2022. So it's coming. So this is what it looks like. You can have an individual station. In this case, the one here in the front has a chill beam center system with a couple of LED lights and then a ionization system. I think that's what that is. Or it might be a projector. I forget which ones those are. But anyway, in this case, everybody can have their own air conditioning control. So let's change gears again, talk about plumbing. We're going to go through here pretty quick. If your building's been off for a while, you want to flush the plumbing because the chemicals deteriorate over time. And the chlorine and that the building or the water treatment folks and the water supply folks put in deteriorates after a while, and that's one of the problems we're having. We're using less water, so the pipes aren't getting flushed, which means by the time it gets to an end of the line on a long pipe, it might not have chemicals in it anymore, or might not have active chemicals. So these are the things that you're talking about, figuring out what's going to corrode the space, flush these things out, and then test the water quality. It's good to do this periodically. With air systems and all of the rest of things that have human contact, you need to be sure that that stuff's pure. Another thing you need to be careful of is water temperature set points. A lot of people on their hot water heaters set them at 110 degrees because that's what comes out of the faucet. Well, interestingly, Legionella thrives at 90 to 110 degrees. So if you have a lower temperature hot water heater, maybe a issue with sanitation issue with Legionella. So you want to be sure that the systems are set to 140, if at all possible, and then have a thermal mixing valve that sets it down, because you don't want to put 140 degrees into a lavatory that people in the office or children with that because it'll scald them. But in looking at all of this, be sure that all of the circulating stuff works right, and all of this stuff is calibrated and tested periodically. So some of the new stuff on the plumbing, net zero systems. We're looking at rain. We're looking at these are lead based type things now, but they're starting to appear in codes. We're starting to get requirements for condensate recovery and for recycling. Some of that water treatment system is going to depend on location and controls. For example, we're working on a warehouse system right now where they're using the condensate water off the air handlers, air conditioned warehouse, and they're using the condensate water into a tank that they're using to flush their urinals and water closets. So it's coming. You talk about water storage in some places, like for example up northeast, you have to have a water storage tank on the roof for fire protection. Then there's you be careful about all the piping, all those materials change, and all of you in the plumbing code business certainly know all about those. And the fixture efficiency has changed, and those are getting more and more efficient. Good news and bad news, but getting the water use down is important. But one of the things that we're seeing some designs nowadays that they're going to have a single restroom layout. There are going to be no more men's and women's rooms. It's going to be one restroom, and everybody's going to share the same restroom, which is going to be interesting. It's going to take some getting used to. Then Internet of Things keeps you a record of all of those things. That's what some of the new fixtures look like. It's going to be interesting. We're going to have to get used to some of these. But this is going to affect the utilities, the funding and regulation of the utilities, and also landscaping. How much can we use for landscaping? Electrical, net zero buildings, and I'm running out of time here, so we're just about finished. Net zero buildings, we're talking about generation and storage. The UV or the photovoltaic panels on the roof or on the ground are great. Great when the sun's shining, but not so great when it's dark outside. So you need storage. Storage is coming. It's getting to be a lot bigger area, which is, we're going to start seeing that in codes. The PV panels are now part of the codes, and you have to have special disconnect capabilities for PV panels. Be sure the fire department can turn them off. And you need to be able to generate those and to store the energy if at all possible. So there's various different ways of, like I say, solar, wind power, windmills, combined heat and power, chemical systems, all generate energy. This is going to affect your utility systems. Some of these things to be totally disconnected from the utilities probably won't happen for quite a while. So what the utilities are going to have to do is they're going to have to build for capacity and potential use. So if you need backup to your systems, or if it's dark for a long period of time, you got PV, then you might need a backup system. But the utilities are having to deal with this. Net zero devices, you were talking about computers, communication sensor, all that kind of good stuff, have low power usage, but still going to need power. So one of the interesting things from a power standpoint is local electric power generation is direct current based. And then in the case of the PV panels and the rest of that, and it generates in direct current, but direct current can be used, and demand control systems are, can be cloud based. The PV systems, depending upon where you put them, said, well, there's not enough roof for systems to power the building. Well, you can put them, windows now are photo PV capable. Wall panels are now manufactured that can generate electricities. But all of these rest of these things can be device integrated. For example, your computers, your lighting, all the rest of that can operate on DC power. So as I said, the batteries and all that have to be, have to have space for them. You got to have a code around them. How do you use them? So where's this going? Well, it's going to digital power, direct current digital power. We're not going to have those same kind of panels. We're not going to have wiring and conduits. We'll have power distributed by Cat 5 and Cat 6 wiring. And it's going to be providing the power and control of whatever it's connected to. And lighting in this case, if there direct current with digital power can be individually controlled. So one of the interesting things about digital power, the digital breakers and controls, digital breakers are 3,000 times faster than mechanical breakers. So you can control things a lot better. And daylighting and lighting controls don't have manual switches anymore. So all of those things can be done with the digital power systems. Wireless controls function real well with that. And of course, you need smart systems to take care of that. So what I want, that's going to try to go through what the digital electricity is here, because it gets pretty complicated. But on the right side, you can see what a digital power breaker and panel looks like. And we're going to be seeing more of those. And there is some computer systems, computer centers now that are set up with digital power. So it's going to be interesting. So LED lighting, most of us know about that. They're looking at 130 lumens per watt right now. It's going to get better to 250. But all of these various things are controllable. Again, just saying, I want LED lights. Well, you need to make more decisions in that. Color, rendition, all the rest of that LEDs have a lot more capabilities, but you need to decide what you want and be sure that you get exactly what you want. This is what some of the new LED fixtures look like. So what's in summary? Try to summarize all of this. Figure out what you want. What's the building capable of, and what do the people in the building and the processes need? What are the current standards? What do the people need? What do the buildings need? What do the code needs? And then you test it to be sure that it does that. And in case, maybe detail testing. Figure out if the systems meet those needs. Tune them up if you can. If they don't meet the needs, then you got to make some changes. And if you do, you're going to have to train the occupants and operators. Quite often, people don't realize that the occupants need to be trained too. And you need documentation. So all of that needs to be left so that the building maintenance folks and the operators know what the building is supposed to do. So there we are. That's summarized. Jason wanted me to put my picture on here so you know what I look like, so I did. But
you've had a haircut since then, Jerry.
Yeah, right. Well, nowadays you're not supposed to visit the barber. So anyway, that's my email. So shoot me an email or whatever, or send it to Jason. He can get me the stuff when we're here to answer questions. What you got?
Yeah, that's I've got a couple comment. Oh, just trouble logging on. I guess we haven't had. You must have just done a very thorough job. I've seen we've had a lighting and controls webinar about 18 months or so ago, and some of the control panels going into these buildings are pretty impressive. And that's for the code officials on the call that have been somewhat reticent to enforce the commissioning aspects of the energy code, which pretty much whatever energy code you're on, certainly the 2012 or newer, even though we should all be on the 15 or newer, there's, on the commissioning requirements from a code official's point of view, a lot of times requiring that initial commissioning letter from basically making the owner aware that the commissioning is required, you can provide some value for that building owner that he didn't even know was there, rather than just ignoring those completely. And a lot of those commissioning requirements and in engaging a commissioning provider will help kind of cover a lot of this stuff that Jerry mentioned today. Are you seeing one thing or the other that is, yes, Stephen asked if you will get a copy of the PowerPoint, and he also said great presentation. Are you seeing one particular method being more prevalent than the other, or it's just kind of hit and miss depending on the mechanical engineer on record, or is there a specific way you're seeing most of these buildings using these days, Jerry, or is it kind of all across the board?
Well, what we're seeing is even in our area, just a vast amount of variation of enforcement of commissioning. We've got people that in the commissioning industry that in commissioning, is back up for a minute here. In commissioning, you need to have people review the drawings and be sure that the commissioning requirement is there, and this is in the code, and the commissioning requirement is there, and the building official knows who that is. Then the commissioning, in addition to plan review, needs to be out on the job site and looking at things and working with contractors and having contractors do testing. And the issue there is not only, from a commissioning standpoint, is not only with contractor quality, it's also design. Because what we find nationally is about 30% of our commissioning issues are design issues. So that things don't work as well as they are intended or aren't defined real well. So some folks that have energy code reviewers, some of the reviewers, for example, in our area, like some of the cities, have very few of the cities around in Dallas-Fort Worth have their own energy code inspectors. Most of them use contract folks or independent certified folks, but some of those folks don't enforce commissioning at all.
Right.
Don't even call for it. And some of the folks that do commissioning don't even visit the job site. So there's a lot of issues there. The new IECC, I haven't been able to talk my contacts in ICC and get me a copy of it ahead of time. So they're still printing that. Sometime in the first quarter, they say they come out, but there will probably be more commissioning requirements in the 2021 IECC, which probably, I don't know what you heard of, Jason, whether this legislature is going to boost that from the 15 to the 21.
No,
but the 21 probably will have more more commissioning requirements, because if you look at the 90.1, the 19 version of the 90.1, which is the energy code it's based on, virtually every one of the systems that has a small paragraph that requires commissioning.
Okay.
So it's good for the building officials, and it's a value to the owner. And yes, they have to they have to spend a little money to get the commissioning done, but the payback is anywhere from a few months to a year or two to having commissioning done on a building. And I'm talking about new buildings. Now, existing buildings, you have the same issue. And I mentioned the school we worked on. And we just did a study on an office building that was sort of a recommission. And what we found is that the condenser water isn't adjusted right. And there's like 5 air handlers that have outside air capability, but only one of those air handler rooms had the outside air open. So they weren't getting any outside air to the building. So that's a health issue. So commissioning is really important, we think, and it doesn't increase any cost to the city, but it does to the building owner potentially. But if they know from day one that they have to do commissioning, and the code now requires that there'll be a commissioning provider selected at the design stage, and that there's a commissioning plan written that is available to or submitted to the building official before you get your permit. Right. Now, some of the cities now require on an energy code review at the inspection at the end, and they need either their city form or the ICC form or a letter that says the energy code has been complied with. When we do that, we insist that the commissioning also be completed. Or up to the point where it can be. But we've got another commissioning thing. I think we've done this with your folks, Jason, on commissioning, but we can do that again if people are interested in it. But commissioning is important to the operation of the building. Is becoming more important because the health of the folks in the building depend upon those systems operating right.
I'm a big Shirley Ellis, and I joke all the time about how if we really want to save some energy, go back and retro commission all the existing buildings, and we'll really save a ton of energy.
Yeah. Well, there's a university.
Yeah.
There's a university that was in an office building. This is another quick story on campus that wasn't operating real well. It's an office type building, so they recommissioned it. Reset everything, fixed everything. Everything was really not more, 20, 30% more efficient. Then they said, what happens if we let it go for a couple of years? Mm-hmm. 3 years later, they did neither normal or no maintenance, and they didn't commission anything else. 3 years later, the building was operating as bad as it was before they started the commissioning.
Yeah. It's a continuous process, and anyway, great information, Jerry. We're a little bit. We're 15 minutes over, so I'm going to go ahead and stop it here. Thanks for joining us, everyone, this morning, and thanks again, Jerry. I will follow up with that contact you sent, and everybody have a wonderful Christmas and a happy New Year. This will be our last webinar of the year. The field trainings, hope to get back out in the field. I have one in Victoria on January 6th, and we'll try to socially distance and be as safe as we can out there, but I'm tired of being in the house, so we're going to get out in the field. Shoot me an email if you're interested in some field training. We'll get that scheduled. And for you building officials, join Spear. Have your city join Spear. Thanks, everybody. Have a great day. Thanks again, Jerry. Merry Christmas, and we'll talk to you soon.